right, we've got everyone. Welcome, everyone.
Hello.
Good
Hi there.
afternoon. Good morning.
Good morning, good afternoon. Depends on where in the world you are. But yeah, I'm joined by three panelists today. So this is our Rust in Safety Critical Systems panel. And I'm joined by three folks, and I'm going to go down the list here. So first we have Jack Greenbaum, who's the Senior Director of Engineering at Green Hill Software. Jack, do you want to give yourself a short intro?
Sure. I'm involved in the development of both embedded systems software products and embedded systems tools at Green Hills. I'm part of the advanced products team, and we do engineering services and customizations of Green Hills products. So I spend a lot of time sitting with our customers, listening to their requirements and shepherding solutions to them all the way through, including certification of, functional safety certification of software.
All right, great. Thanks so much. Next up, we have Nathan Ashbacher, who is the CEO of Oxon Corporation. Nathan, do you want to introduce yourself real quick?
Yeah, sure. So as James mentioned, I'm the CEO of Oxon. We're the smallest of the three companies that are represented here. We're a startup that actually uses Rust for active development. In fact, almost entirely Rust, save for some Clojure that we write some parsers in because of one particular Clojure fanatic on the team. The company's sort of goal is to build engineering tools that are, if anybody's familiar with sort of like the CAD, CAM, and finite element analysis tools, things like that, that mechanical and electrical engineers have had access to for many, many decades. So try to modernize the sort of software development tool chain to include things for analyzing system behavior, kind of at the software hardware boundary level. So a lot of embedded systems, things like that. I've been using and following Rust personally since I think 2011, like a long time, back when it was systems Erlang to me before it became like better C++ in some dimension. And so I've been following it along the entire time, and I've been trying to get it in use at different places that I had worked, and then finally just had to start a company so that we could use it for real.
All right, thank you so much. And our third guest today is Nicholas Corcockas, who is a software architect at Volvo Cars. Nico, do you want to introduce yourself?
Yeah, thanks, James. My name is Nico. I'm working at Volvo as a system architect. I'm very happy to be here with you. It was a great day. My role at Volvo is a system architect designing our next generation platforms. One of the things we are really into is creating safe products. Volvo has a huge history in that since the first seatbelt. And I need to give a shout out to our project EVA, which is an open source of all our safety research for the last 50 years. Back to you, James.
Yeah, thank you very much. And for those who are just joining us for the first segment today, I'm James Munns. I'm a managing director at Ferris Systems. I'll be acting as the moderator today, and my background is in a variety of safety critical software development, including avionics, gas detection, robotics, as well as some non-safety critical fields like IoT. So we're coming together today to discuss Rust in safety critical systems. So as of today, it's not generally possible to use the Rust programming language for safety critical software development, at least in regulated industries and things like that. However, Rust is really getting to a changing point on that in terms of making the moves towards being ready for safety critical systems. And we feel that Rust has a lot to offer safety critical systems. So we're going to be talking as a panel for the next little less than 60 minutes or so. So if you're watching this on the stream, we would love to have you ask questions the last 30 minutes. So we're going to be talking for 60 minutes and then 30 minutes of Q&A. So if you have any questions throughout the panel, please feel free to throw that in the matrix room for the panel. We'll have people collecting those questions, and I'll pull those up for the last 30 minutes of this 90-minute panel, and we'll have a little bit of back and forth. So without any further ado, I'd love to start off with just the broad question of what makes safety critical systems different from other software or electrical systems. What really makes the difference when you're designing software that's designed to be safe for humans? So I'll kick this off to Jack, because I know you've been talking about safety critical already a little bit today.
You know, I think designing for testability is one of the things that's different. The level of rigor in terms of requirements coverage and test coverage really makes you think, especially about error handling. Who's gonna respond to this? Is it anyone? Am I just going to punt completely? I mentioned in my talk yesterday that a blank screen is a safe state in an instrument cluster. So given all the assurance activities you have to do, you might just punt to that more frequently, or just design your code to handle errors more easily, because you're going to get a big one. So don't worry about the little ones. I hope that was a connected thought.
Yeah, definitely. Nico or Nathan, do you have any thoughts about what really makes, when you're designing software that's not meant to be safety critical versus safety critical, what switches in your brain when you drop into a safety critical project?
Well, I mean, there are certain things that we run into with our customers in this sort of changing world, especially for us, where it's sort of systems of systems, so you're getting some composition of big behavior, like in a chemical refinery or something like that, relative to a single component where, folks have to, it's sort of like, it's kind of like what Jack was saying, where you're spending your time thinking about, like, how is this going to go wrong? Right, you're spending a lot more time doing that because it may be near impossible for field deployment reasons to actually update the thing. So you get one shot at getting this thing to be, working, whether it's launching it into space or it's buried in the bowels of it's 20 miles underground, something like that. There's another part of it, which is it may just be difficult to update it and sort of discover changes and push something out there. Because of regulatory requirements, right? It's a lot of work to make a one-line code change, maybe like a $15 million cost to do all the other stuff that you need to do to get that deployed out there into the system. And so this puts a lot of much more onus, and I think this is some of the tension between sort of traditional software development and safety critical development, is it puts so much more onus on the ahead of time, like move slow to go fast is like the way you have to do it in the safety critical world. In the more sort of IT and consumer world, it's a lot more, it's a little bit more like the colloquial, like break fast or move fast and break things kind of thing, because you can patch it, get it out there, change it, right? So that's a pretty big difference. I've been on both sides of this, both in the mechanical engineering side through my the unsatisfying part of my career working on things that weren't critical, now to the part that I like on the critical things. And it's a very much like failure first mindset. Like that's where you have to be. And it's much less about feature development and much more about like, how is this going to, harm me, the physical environment, the end user, the other people that are adjacently, around the system. So it's quite a different like mindset you have to put yourself in.
Yeah. Oh, I think you're muted, Nico.
Right, and I would like to follow up on this morning's early morning presentation for us in Europe from Zach and you, James. You gave a great introduction for this slot and what a safe system is and what it's not practically. And I would like to add a few things on Zach's presentation. I was saving it for this session, actually. One of the things is that one of very interesting things, this is a trivia, by the way, of ISO 26262, is that it does not address the nominal performance of an electrical or electronic system, which is it's amazing. What it means is that if you design a braking system, for example, to be 500 Newton meters of torque, and this is not enough. If your requirement says that this braking power is not enough, it's fine from a safety perspective. However, if you design it to be 500 Newton meters of torque or whatever, and then the system doesn't deliver that, this is considered a fault and eventually leads or a failure. So, of course, as an automotive industry, this theoretical barrier is not there in practice, because we always want a safe product. We really want to have a product that will never harm a person or affect property or life or whatever, whether you're an occupant of that vehicle or outside. And of course, everything I'm going to say here is revolves around automotive, because that's my proverbial hammer. Right. And in addition to that, as another pitch to Jack's points, but maybe, we have a lot of systems that depend on that protect our lives in a modern car, and all those systems we hope and we trust that they will be there when we need them, like brake or acceleration, or when you really press the pedal. So in general, Rust comes as a system to develop all those functions, because for an OEM, we only see functions. We don't care what compiler is going to be used. We want our function, which is a high-level use case, for example, will be served correctly and accurately. Yeah. And
yeah, it's really interesting. I mean, when I go around the room and ask Jack what it means to have safety critical systems, he talks about handling errors, which really comes down to a lot of planning on what is acceptable to handle and what it isn't acceptable to handle. And Nathan mentioned a lot about planning ahead, because you may not be able to just change things at the last minute. You really need to put thought into your design, and you really need to think about what your system is doing. And then going to Nico mentioning ISO 26262, as was mentioned in Jack's presentation earlier today, all of these safety critical industries have a lot of stringent requirements that are really just processes to help the engineers think through what they're building and how they're building it, and making sure that they're applying some level of rigor and process to that. And I think that's one of those things that is really different versus other systems where you say, oh, we'll figure it out as we go, because we're always adapting kind of to the last minute information. But for safety critical systems, it requires a lot of forethought and planning, because you really do need to kind of write down what you're going to do it, and then say that you did it correctly. And that's one of those things that's really different for people not coming from safety critical industries, who might not understand why we can't just throw the Rust compiler into a safety critical system, because we know that there's some level of regulation and things around that, but it really does come as a surprise to some people that there's such stringent checks that say you really need to be using specific tools. I'm interested if anyone has any comments on what it really means in that delta of having to think about what you're going to do, not only because you need to make sure you get it right, but also because you need to document all of the things that you're doing to get it right.
And perhaps the compiler is not the most expensive part of that process. I mean, if you think that we are building a Rust component based on Jack's presentation, using a static leap approach, where your Rust component is an add-on to the Integra platform, let's say, then in that process, whatever we build, it needs whatever crate we pull. This also needs to be a safe crate. It needs to have followed the full qualification. It needs at least to have been qualified at some point in time, or to have been developed as an ISO 26262 component, software component element. Which means that the compiler is something that you need to qualify, but your environment is also another thing you need to qualify. And that's one thing that was missing from your presentation, Zach. I think and perhaps you can help us with the effort. How much effort do you need to qualify the compiler versus how much effort is to qualify the Integra platform, for example?
Yeah, that's interesting. The tools qualification problem is really there. In some industries, they just skip it and qualify at the binary level. They don't qualify the tool. They don't trust the tool. So they provide assurance at the code level on a binary. They're not talking about line coverage. They talk about binary block coverage. So you can avoid qualification if you substitute other assurance methods. But 26262 says you're gonna qualify your tools.
I was hoping that I was hoping for something like the tools are developed as an ISO 26262 standard, which means that they don't need qualification, and because they are developed as an out of context element.
Well, the integrity kernel is developed as a safety element out of context, but the compiler and even the runtime, these aren't safety elements. They're qualified components, and 26262 has a separate process for doing that. So it's a different level of rigor that recognizes that even though the product can inject a fault into the system that the compiler is not present on the item. So the compiler is not part of the item. So there's less rigor on the qualification, with the recognition that all the supporting processes will catch anything.
So to zoom out a little bit, I know during the introductions, Nathan, we were talking about being sort of new to ISO 26262, and I know a couple years back you said you kind of got the crash course of what it meant to develop a safety. That's a poor choice of words for automotive, certainly, but you got kind of the learning experience of what it really means to develop a component that's designed for ISO 26262. So for the folks at home who haven't necessarily been through an ISO 26262 process or don't know what qualified or what safety in context or safety out of context means, do you have kind of a bridge of the gap there for someone who learned decently recently what all of this vocabulary and things like that means?
Yeah. Oh my God. So I'll give you like a little brief story, which was, so I came out of fintech. And there's something about that I want to like kind of latch onto this in a little bit, but came out of fintech and then ended up going to work at become the CTO of a company, a startup working on autonomous vehicle sort of infrastructure tools, like not the brains of the autonomous vehicle, but like the skeleton and muscle tissue, right? And on the software side, and I had to sort of get myself indoctrinated into the automotive industry, and kind of it was all the frontier stuff. And, there was not programs underway, but programs that were going to happen. There was all kinds of uncertainty. I would ask folks at different OEMs, well, how are you going to make this AI safe? Like, I assume that that's a thing you have to do. And they would say to me, well, we'll follow ISO 26262. And I just would believe that at first. I would go, I guess they have an answer, And so this happened enough times that I went, I should probably know more about this ISO 26262 thing. So then in an April, I remember the month because it was the whole month a few years back, I just sat through, I got myself a draft of the second edition that hadn't come out yet. And I read it from end to end twice. And it was the most depressing time of my life.
Did you understand it after only 2 readings though?
No, because it's circular. Like the thing, it doesn't actually tell you really what to do. That's the biggest.
Almost. Once you know the secret words.
Yeah, sure. Like it tells you certain things like to do, but it doesn't necessarily. It's not entirely prescriptive about how to go about, like what is the set of technologies and things like that you should use, or certain. They kind of call out. There's like a weird hybrid between like certain types of testing practices and types of verification, but nothing that just goes like this is how you do it, right? And you follow this script.
That's right. They might say you need this work product, but not what the sections of that
what's
work
supposed to be in there, right? And how do I generate this thing? And how is it okay to generate it? So that was really frustrating. But what mostly stuck out to me was how, at least from my perspective, was how ill fit the standard was for the types of software that were going to need to be built. Because it was very clearly designed for designing electrical systems, and software was kind of like where software is going to be maybe 500 lines of a control loop like implementation or something like that, not a pile of like massively interconnected, data flow, crunching, camera images, like all this stuff. And so that was and so then I would go back to all those people that I spoke to in the auto industry and go like, this doesn't make any sense. Don't tell me ISO 26262 because that's not going to work for this. And so that was, I think, how I got any kind of notoriety, was being like incredulous about the premise of the entire thing. But we ended up putting the whole company through training. So we had about 24, 25 employees at the time, and we put everybody, front desk people, product people, business development people, through ISO 26262 training. And being like a company full of like largely curmudgeonly people like myself, we were just indicting the thing the whole time. So, the fine folks at KVA, Jody at KVA was so gracious. He was the one who conducted our training. And the whole time I'm going like, so is there any scientific evidence that this actually produces a safer system out the other side? And he's like, well, I mean, like, I haven't read a study about it, so I don't know. And I was like, oh, okay. And then we just kept like marching through these things. But then sort of to Jack's point, it was like at the end of the day, we went through the training, we all took the exam, like we all passed. And then we were still left going like, all right, well, we went through the training. We know what the words mean now, but I still have really no idea how to start doing this. And that was like a very kind of like frustrating bridge to get, like, I just had to go find assessors. I became friends with people who were assessors at like TÜV and went like and asked questions or asked KVA questions. So when you work with other companies, like, what do they have to do here, right? And we were sort of like groping our way through all the things we had to do. And the most painful part of it is when you realize, despite your best efforts, or you did something that you know is kind of like better than what the standard says, and nobody's going to understand it, and you have to roll back and figure out a way to do something else. So like a specific example of that was, not everybody was familiar with property-based testing that I would talk to. I know Volvo did a case study quite some time back with Cubic, and I've been a property-based testing guy for forever, just because of my roots in Erlang. And nobody knew what to do with these results we would show. We go, here's the test results. And I go, what is this? Where are the unit tests? I go, we don't have, those are not useful here. Like we have these. And so instead of presenting the property-based testing results, we just made it so that we captured the seed, like the generator. Basically, we gave them like reams of thousands of unit tests that were just the intermediate state of the property-based tests to like satisfy this regime. And that's something I wanted to just like touch on really quick, was that one of the things that's been kind of interesting to interact with in this transition between these industries or these domains is that, like, when I came from Visa and I had to do things like figure out how we were going to, provide like both physical and virtual security of systems that were going to be deployed in remote environments that were, relatively low trust compared to like the central mainframe stuff, right? We had a lot of rigor around, the build process and how the deployment was going to happen, chain of custody of things. And I kind of assumed that because in say auto, because of ISO 26262, that it would be somehow better than that. Like that I would like learn how to do that stuff even better, only to discover that a lot of the folks in some of these industries are way behind the curve. Like they actually don't have modern adopted ways of doing these things. And so, for my opinion, is that it actually impedes both like the progress of innovation, but also the ability to produce like an actually safe thing, right? Not that like we did like the ceremony of safety, right?
Yeah. So I definitely want to cut in there because I think you touched on a couple of really great things. So in particular, you mentioned that these kind of standards evolved when software was still very young. So when software really was 500 or 1,000 or 5,000 lines of code. And I definitely think the safety standards, so the ISO 262, the DO 178Cs, the 61508s and things like that, they definitely take a very statistical risk-based analysis on what it means to develop a safe system, mostly through kind of asking you to think through certain problems and provide evidence of those kind of problems. But it's been really interesting over the last couple of years because the complexity of software over the last 5, 10, 15 years has really, really gone up exponentially. From even the last 5 or 10 years, designing a piece of software that was really just, it's measuring an ADC and then it reacts based on that. And now we have systems that are providing telemetry live to the internet continuously. And you have dash cluster systems that are connecting to all kinds of components in your system, either for software update reasons or telemetry reasons or things like that. So it is definitely something that this industry has gone through a lot of need to change for the last 5 or 10 or 15 years. And hasn't done a lot of change in the last 5 or 10 or 15 years. So, I mean, based on our investigation from Ferris Systems, when we were looking for what was the last programming language that got qualified for safety critical usage, and we haven't found a new one that's been qualified in about 20 years. So there's been iterative updates to language like C, C++, and Ada. And there's been some model generation tools and things like that either generate C code or Ada code or other things like that. But it's an industry that is very much resistant to change for some good reasons and some bad reasons. So the good reasons are, the properties of the systems you work with, which means you can make really good guesses about those because you know how they work and you can predict how they work. And safety critical a lot of the time is not about performance or anything like that, but it's about designing predictable systems so they work in the way that you design them. But we're starting really to get a kind of into an elbow curve of complexity of software where we're really seeing all industries. So I mentioned that 70% of memory safety issues seen by Microsoft and Google and things like that. I've really started seeing those kind of things in the safety critical industries as well. And those are something that we hope that Rust can help with, but we've seen a lot of resistance despite there still being these problems. Have you, Jack or Nathan or Nico, have you really seen those problems, not just in a web browser or an operating system? Have you been seeing these same kind of issues in safety critical systems as well?
Yeah, I think a lot of it's cost. Code lives so much longer than you would ever expect. So a lot of the inertia is technical debt, old code, old standards. People think it costs too much to recertify. So, I think that's one of the boat anchors here. And so when I look at Rust and the emphasis on a strong foreign function interface, that, gives me hope that we can bring Rust in and eventually that old code will age out and die. And we can have a better system that realizes the benefits that we all see from Rust.
Yeah, so this is probably a good time to zoom out. So we're definitely all here as people who are at least fairly interested in Rust and fairly interested in seeing Rust in the safety critical space. So this is probably a good time to expand about what kind of ambitions do we have for Rust in safety critical systems. So Nico, you mentioned you've been doing a lot of investigation of Rust lately. Do you want to share a little bit about what your ambitions are for seeing Rust in a safety critical industry?
So at the moment, we do believe that the presentation you gave earlier this morning, James, it's quite accurate, if not optimistic, about having a safety certified system in 2023. And I'm saying that with all honesty. Today, every kind of embedded system you want to have will include necessarily the headless crate, for example, right? And if you want to have a safety qualified system, you need to qualify the headless crate. Regardless if you link it to using an FFI to the Integra platform or not. And that goes for other crates that are also equally oftenly used on your system. So at the moment we are not we have a project running with Rust, Volvo, but it's not safety relevant because we cannot have a safety relevant system today. That's our assessment, and I think everybody would agree in that panel. Yeah, the future is not that bleak though. I mean, but the cost to enter that system, given that today you have a model-based design system where you have your Integra, for example, in Zach's example, and on top of that Integra, you have your MathWorks environment, which will generate C code that will be automatically compiled. We think that the cost of transition is very high in order to, and the benefit it gives you is small because your model-based design environment gives you similar guarantees to Rust. So in my humble opinion, and that's absolutely not Volvo's understanding, the greatest point of Rust is ergonomics. It's fast iteration. It's the things that come from the toolchain. And if we try to follow this example with static clips, it will be like running with weights on our feet. It's a real thing. I mean, if we could, Also, such approach will lead to to a vendor locking. I mean, say that I want to implement some safety function using some security, right? I want to use the Rust crypto, right? But I won't be able to do because the Integra will take precedence, will control all my cryptographic credentials. So I need to access all those crypto hardware via an FFI, which is not portable also. So that's my view. I mean, Nathan, Jeff.
Yeah, I mean, that's where I want to start with this. So something, James, that you said about, with the goal is to try to build predictable systems. I think that's actually it, right? So every single safety critical or safety element out of context comes with a developer interface agreement, which is like, we did all the things that we think we did to make this thing safe and behave a certain way. you're going to now take this and integrate it, and you better follow all the rules that we say in this developer interface agreement. Otherwise, no assurances, right, on like what's going to happen here, right? And so, and this, when I encountered that, what it reminded me of, or the challenge of doing that reminded me of a problem that has been forever the case in sort of formal verification and formal methods like ecosystem, is the chaining together of assurances, right? That I can actually like say something meaningful going from, say, like model checking to my implementation. Like if you were, it just happened at Strangeloop. One of my engineers was giving a talk about TLA plus, or at, not at Strangeloop, or maybe it was Strangeloop or the ICFP, I forget. But, you know, he was talking about this thing that we did with TLA plus, and then somebody asked the question like, you know, well, you know, how do I connect this to my implementation? And then like, there was just like general scoffing from the normal like TLA plus, like, you know, ecosystem, like that's silly. It's a design tool, not for programming. And, you know, which is true, technically speaking, but if you really want to try to build predictability going all the way from the requirements down to the implementation at the binary level, maybe crossing the boundary into the hardware level, it's very hard to like compose these assurances and make sure they actually like link together and that they're meaningfully a refinement of one another, right? Like all the way down the chain. And that's one of the things that where we started to leverage Rust originally. So before we raised money and we're a product company and we were trying to figure out what we were going to do, we were working on a project for an autonomous vehicle platform that needed some communications related stuff. And our job was basically to help them understand like how this system was going to tip over. You know, like they were given some silicon from a vendor, and they were trying to get some sort of like safety and redundancy guarantees in place. It was a lot of the system architecture was built on the premise of time-sensitive networking stuff, which is a draft protocol, and it's implemented weird and has all kinds of edge cases. And so, you know, while there was a lot of like predictability in like a single component that we would interact with, it was the composition of a bunch of components that suddenly now interact with each other, and you get what sometimes in resilience engineering world is called like resonant failures, where every single modular thing is fine. You can build it, get that developer interface agreement, right? And then stick it with a bunch of other stuff, and everybody followed the rules, and it still doesn't work, right? And there's some kind of catastrophic failure.
What a surprise!
Yeah, and so one of the things that I think Rust is a building block for, or was for us at least, was we started to do things like, and we have like a little open source thing that you can go look at, which is like a little assured like Bitfield register like library for embedded development. But the idea was, well, let's lean into the facilities that like Rust provides us. Let's not start at C. Let's start at Rust and leverage some of the, you know, what would in many ecosystems be idiosyncrasies of the way that the type system works and the substructural types through the borrow checker, and make it so that it's basically either impossible for this thing to fail in these like sets of ways at compile. We'll notice at compile time, or in sort of going back into the sort of predictability land, that it will fail at exactly this place. This is the only way that this can go wrong, and I know exactly in the chain of composition where I'm going to notice this issue, right? And that's, I think, a really sort of useful building block, because it starts to give us ways to connect the dots between like all these different things that we have to do to make a safe system, and build on the abstractions in a way, instead of just going like, well, I wrote it all in C. Is that connected to my design? Who knows, right? Like I wrote down a model. Is that connected to my implementation? Maybe, right? And Rust provides like a nice set of facilities like through MIR and sort of the way that its type system works to sort of like link these worlds together. And I'm hoping that what I think like can be enabled out of that is that we can accelerate certain types of development, so that we're not, you know, like there's probably a graveyard full of products that like, and companies that have existed to try to analyze C and make it be, you know, like as assured as anything that you could possibly be. So you only write the thing one time, you know, all these things. And everybody ends up solving the first 40% of the problem over and over and over again, right? Because each one is kind of a niche thing, and it doesn't get like broad scale adoption. Rust incorporates a lot of those interesting facilities in a way they're not quite all the way there, but you can kind of see the light at the end of the tunnel in terms of language features and tooling and kind of where the community is taking the language, that I think can make it so that there's like a new step function where you go like, well, we're not going to we don't have to worry about making weird annotations for linear types to do things in C, because we can just model them directly in Rust in the type system. Things like this.
Yeah, Nico talked about ergonomics and feeling like we've got weight on our feet. And Nathan is talking about accelerating the pace of development and being able to think compositionally instead of down in the details. And I think that's our aspiration as well, and my aspiration. The first things in my head when you posed that question, James, were actually things I never want to do again.
Yeah.
I never want my team to ship code with a memory leak ever again. I don't want to have to worry about, I'll just say I don't ever want to program in C++ again. The abstractions there.
Oh, snap.
Well, I'm a guy who started Lisp was the first language that I wrote a program more than 100 lines in. I've actually been paid to write Prolog professionally.
Oh, you're lucky.
So, I cut my teeth on ill-structured, loosely typed languages. They really aren't fun. And then C++ with abstractions that they overload things there. I like Rust. It's clean. It doesn't overload concepts like pointers. And this is what gives you the ability to think at those high levels, because it breaks us from the old abstractions tied to memory that are really assembly language and original old computer architecture concepts. Rust lets us think about them in powerful ways where we don't worry about aliasing and multiple access, because you just don't do that. And once you stop doing that, then you can really think about the problem you're trying to solve.
So I definitely want to zoom out a little bit. I think we're probably all on the same page in terms of we think that the ideal outcome in 20 years is that at some point legacy systems do get replaced by Rust, that in some way in 20 years that hopefully all safety critical systems could be written in Rust, because we think that generally Rust as a language provides better developer ergonomics, or it provides better safety guarantees, or as Nathan was mentioning, gives you more powerful tools to encode your invariants, the ways that you can let the compiler enforce the things that you want it to enforce. And it's really interesting to hear this conversation of how we think we're going to get there, because that's really the conversation that we're having right now is what are the next 5, 10, 15 years look like when it comes to that transition time. And it's been really interesting to see this pattern repeat through a couple different industries. So definitely when you talk to someone like the Servo team at Firefox, they had a huge system where the reason that they developed Servo was as a test project. So Servo was an alternative browser is an alternative browser for Firefox. But when it came to integrating Rust into Firefox, they didn't say, we'll just reintegrate or we'll just start by rewriting Firefox from scratch, because they realized that if they did that, they'd be at a point where by the time they were done, Mozilla wouldn't exist as a company anymore, because it would take so much effort, because a browser is such a large, complex system that has so many parts, from a layout engine to a JavaScript engine to things like that, where they realized the only pragmatic way for them was to start dissecting these things by parts and making sure that they had the tooling to integrate it. Whereas we've seen other people in the industry realize that they started doing that, and they realized there was such an impedance mismatch between what they wanted to be doing in Rust and what they were already doing in C or C++, that at some point it made sense to do some kind of a switchover or an incremental switchover. So I think this is going to be one of those things that it really is going to depend industry by industry. And safety critical is interesting because, as we mentioned before, you can't just bring a compiler. You have to bring an ecosystem, whether that's the standard or core libraries of the language, or whether it's infrastructural crates like the Cortex-M crate or Heapless or even Arctic, where it really is interesting because you've got to bring that ecosystem. So there's really two approaches to that. There's bringing the entire ecosystem with you and switching over to a new ecosystem, or it's trying to reassemble that ecosystem by parts.
I had this like shower thought about this, like after one of our sort of meet and greets, and I was thinking about, like, I said something on our call that was like, this Rust is in a weird place because nearly everything else has been grandfathered in, right? So it's not entirely clear how this even happens because everything else existed and the standards were then written, right? And at least several of them. And so, but I had this thought, I was like, well, to your point, we have to bring this ecosystem with us. What it calls out in the standards is languages. You have, like, there's, depending on the, like, aerospace standards, they even call it specific languages, and in the automotive standards, there are suggestions of these languages basically, but they're very strong suggestions due to inertia. There's a distinction between, like, the ecosystem and the language. Like, so I wonder if there's a first step, which is just like get the moniker of Rust as allowable, right, as like a thing ahead of the entire ecosystem existing behind it in one of those standards documents, right? Because there's nothing necessarily safe about Java. Like, it's in there. You can do certain stuff in Java according to the standards, but it has a whole bevy of, like, issues, right? Just like C or C++ or any of the other things that are in there. And so to see, like, I'm wondering if there's a way for that to be decoupled somehow, because you have this, like, cart, horse, chicken, egg problem with, like, well, there needs to be an entire ecosystem to support, like, who's going to do that research exercise? Like, the government, to bring, like, I don't think they're that interested in, like, in a moon landing project for getting Rust into safety critical systems. But it would be something of that scale to have to get there to be, like, a Green Hills already and, like, an Infineon already and, like, all these, companies in place to just get Rust, like, on the page, right? Anyway, so I think
there's so many opportunities now to just do Rust. And I really urge people to just do it, because you won't want to go back. So, James, you asked what are we doing to make things better in the long run, and I think people just need to code. It's such a different experience once you get over fighting with the borrow checker and realize that you're dancing with the borrow checker.
Oh boy.
And look at it that way. Once you get over that hump, it just feels good. And if you're a leader listening to this panel conversation, give some of your team some encouragement to go do something in Rust with some of their time. They're going to be happy. Yeah. They're going to like it. And, that's part of the benefit is, it's satisfying to build good code, and it's so much easier to build good code in Rust. So that's a second order effect of Rust that I haven't heard people talk about much. Beyond it's the most loved language.
We get this, like, we talk about this, like, there's all of us got involved in this because we're like, there's got to be a better way. This is awful, right? And that there is a better way. So I think as like a leader who hires those sorts of people, I will say that he's right. You give them an opportunity to write Rust. You better make sure that you're ready to hear about it, though, for the rest of your life after that. Because they're going to go, this is the better way. Stop doing whatever it is you're doing. Do it this way.
So, Nathan, you mentioned getting the word Rust into the standards, and I think that leads into a really good thing about expectation management, is that a lot of these organizations, whether they're safety critical organizations or they're the regulatory bodies, whether they're the FAA or the TÜV or any of these organizations that are generally in charge of checking your paperwork and making sure that you're delivering the way that they're supposed to. I think that's actually one of those really big perception things that Rust is going to have to overcome, is how do you avoid the surprise for an engineering organization when you're a second or third tier supplier and you say, we've built this software package in Rust and we expect you to include it in your car, or as an OEM or a vehicle integrator or something like that, where you say, we developed our braking system in Rust and you take it to that regulator for the first time. I think that's going to be a really interesting experience, whether it's coming from sealed Rust or it's coming from another organization. But in particular, Nico, I'd be interested in hearing a little bit of your thoughts around what do you think Rust could do, or sealed Rust could do, or just this whole ecosystem push could do to help avoid that surprise, and what is this even kind of approach from either an engineering organization or a regulatory organization?
Right. The first thing I need to mention is that perhaps we don't need to replace the braking system. Perhaps we don't need to replace the autonomous driving system or all the safety systems. Maybe Rust is good enough dealing with non-critical functions. Because, for example, the airbag deployment. Why should we replace it if it works correctly? I mean, with the exception of Toyota or whatever that company was a year ago. But why do we need to replace that if it's there, if it's working correctly? Our point of view should be, how do we develop the next cool thing in Rust? Because my point about ergonomics is it's fast to prototype. It should be quick to develop something. It doesn't cost much to prove that, hey, look, if I go and do this AutoSAR stack, this will take me a year just to procure the bloody thing. Well, if I go and prototype my stack, this will be, I don't know, a month, just setting up my stuff, compile it, put it into an SDK, and then showcase it, demo it to people. And yeah, this you can then get traction quickly. Your boss would be more likely to say, yeah, this is fine. Let's spend a month in that instead of 20 person years just procuring something. And that's my point of view. I mean, that's how we should approach it. Maybe we don't need to replace all the braking system, all the engine control software, and we need to do the next cool thing. I will open a parenthesis to something that was implied during this session, that it's better to approach the requirements from a bottoms up instead of a top down. And I understand that in many cases it's frustrating dealing with requirements. Maybe you kind of implied it, Nathan. My point of view is that at some point the engineers that are building a system need to take a step back, look their system a little bit away from a distance, and understand whether it not only if it fulfills, if it works correctly, but if it fulfills its purpose. And that ties with my entry trivia point about that we need to address the nominal performance as well on a system.
Yeah, that's a really interesting point, both from a business and a safety perspective. So there's no, especially in safety critical, people are not going to change just to change. Businesses are going to look at, what does this choice of a new language get me? Is it, as Nico said, the ability to prototype and design something faster or more reliable from day one because you build it once and you're done, rather than building it and you sit at 90% done until you've knocked out all of those bugs that take you just as long as the first 90% took? Or really, from a safety critical perspective, the job, the aim of sealed Rust and the aim of Rust is not, we can complete the safety critical paperwork faster. Like, that's really not the aim of Rust. The goal is that we think that we can build safer systems in Rust or more reliable systems in Rust than we can in a language like C and C++. And not just, okay, we have to do all the paperwork so we can say, yes, Rust is here. We've checked the box. We've limboed under the very low bar, or surprisingly high bar, but and gotten all the paperwork we need. And it's just the same as C today. Our goal really is to really take a step back, because I think at least the consensus in the room is we think we can build better, more reliable and safer systems in a language like Rust than in a language like C or C++.
I do want to play a little devil's advocate, though, and make sure that we don't lose the good parts of C. So, Mr. C gets a lot of funny looks. But when you thumb through Mr. C, I'd say maybe 30% of it actually applies to, isn't C based, but could apply to Rust as well. So yeah, we think we can do things in Rust better, but we shouldn't ignore what we do have from the past.
Yeah, we did.
Nathan, I definitely wanted to throw it over you to your investigation from Polysync.
Yeah, so my prior position when I was at Polysync, you can probably find the little white paper on my LinkedIn. I think it's where we did this sort of like review basically of all the C static analysis tools we could get our hands on. Most of them are open source. We had a couple of commercial ones, like the most popular commercial Misra C thing. I can't say the name because they'll get mad. But it was really interesting to see. Number one, it was a little disappointing. It's like, Misra C checkers are kind of like glorified style guides. in a lot of ways. Now, those things are in there because they were motivated by something, right? They're motivated by trying to make certain coding patterns and things be more transparent to a reviewer who's going to go through line by line and go like, yes, this all makes sense, or I can tell what this is doing, right? Because most of the safety process is a lot of manual humans doing things and like checking stuff and signing off on it at various levels of independence. When we went through it and looked at it, we were like, oh, you know what's funny is I think we can make a Rust format plugin, like configuration, that basically does like what Jack is talking about, which we go, there are some patterns here that are actually pretty good. Like we want these things to be easy to understand. You still want it's great to have all the machine checkability in the world. And that's like a fantastic sort of like verification activity. But it's very hard to do automated validation. About like what is the semantic meaning of the system, like what is it trying to accomplish as it interacts with the world around it, right? That's if you're doing that in robotics, it takes like maybe like a whole bunch of crazy sensors and cameras watching an arm swinging around and making sure it's doing something sane. It's a very different kind of task, and so that like validation of going through and going like, yeah, this looks like it's doing what I think it's supposed to do, or what we expect, how it's like tied to our upstream requirements of a sort of like higher level expectations of system behavior. Still requires humans, at least at this point, largely to be involved in that, and getting some of those nice things that are procedurally nice or kind of like decoration nice from what we do already to better facilitate that, I think is still valuable. That we shouldn't lose that along the way. To Nico's point, like I think he's absolutely right. Like part of my not so much like worrying about things about the requirements from the bottom up rather than the top down, but rather that the ability to compose these abstractions and know what's going to happen. If you think of like how, I don't know how the audience is probably not necessarily that familiar with this, but say like MathWorks Simulink, where you're going through and drawing your block diagrams of how you want your system to work. And it's sort of like you're writing software by drawing a circuit, kind of like node-based programming. It's like a weird blend between using an audio patch bay program and like a circuit design program. And then it generates something out the other side, right? That is C, which is a representation of what that model you wrote down is, and that's great. Like it covers a certain part of the domain to go, well, I codified in a higher level abstraction way this like thing I want to accomplish, turn it into the low level implementation, run it on a piece of hardware that I trust, right? But to be able to go further and further outside of that, to expand that composition to something, a chain all the way from the requirements to the way that they're written, to being able to like generate test cases, to be able to generate a checkable model, to be able to then turn that into something that can go into annotating marking the code in different places. Like you can imagine if like you needed to validate your system behavior, and if I don't know if folks are familiar with CovMark, the coverage marker crate for Rust, where you put coverage markers in there about what the meaning of a piece of behavior is. You go like, this is a spot, like this is a chunk of my code that relates to this feature that I implemented. And I can see that I must have done something that related to this feature to create some like semantic connection or, thread, between there was an intent to produce a feature that did a thing mechanically visible in the implementation because the coverage mark got in there. And that's not going to be like ever a fully automated thing because an end user has to go in and put the coverage mark in the right place, right? But at least gives you like a much faster lens. It's not a software archaeology project to make sure that that what you've created is somehow ties with what you're doing in quite the same way that it is often today. And by being able to do these compositions and have more automated checks, but not even necessarily entirely automated checks down the path, we can build more sophisticated things. Like to Nico's point, like why are we going to replace the ABS controller? Like it does its job pretty well, but we can build all new interesting things faster because we have a way to sort of connect some of these dots more automatically.
If you build the interfaces right, yeah.
Yeah. Yes.
Yeah.
You can write bad code in any language, and that's, we do all have to be real about that.
Yeah, that's definitely true.
Yeah. So that's one of those interesting things is I think there's definitely room for a lot of learning here as Rust starts to enter these, or the first trials start happening for this. Is I think one of the things that we're going to really learn, especially in safety critical systems, is how does embedded Rust work from a systems perspective? Because really understanding how a tool interacts with the rest of the ecosystem is I think going to be a really interesting learning perspective, in that, trying to build systems that have a certain amount of availability or a certain performance over the entire life cycle, where that means, what is it like to maintain Rust systems 10 years after you wrote them? Do you have any thoughts on what you see in the future of what do you think we could learn, or we should definitely keep an eye on for how we see Rust interacting from a systems perspective over the life cycle of these devices and these processes?
James, one thing coming to mind is the conversation that you and I and Jonas have had about sync and send, this whole bare metal sync and send, and how sync and send aren't strong enough abstractions on a bare metal system. That's what an operating system's for. So the boundary between language and standard library and operating system, you can't take it too far. That's one thing that comes to mind with the question you just posed. I'm not sure that's quite what you had in mind, but that's what springs to me.
I think definitely as we push languages into newer areas, we start to figure out where, current abstractions do work or current abstractions don't work. And I think those are definitely areas where there's a lot of unknowns with choosing a new language, but it's one of those things that's definitely going to have to be a learning experience as we go.
Yeah, just caution about veering into operating system territory too far. I've seen examples with C++ threads, for example, where it turned out the customer didn't want the standard behavior, yet he'd purchased a third-party system that used the standard. And the standard wasn't flexible enough. So, language concepts should deal with the right abstractions and not veer too far into system land.
That was actually, so I agree with you now. I would, decade-old me would hate you for that statement. I so desperately wanted, because at the time Rust had lightweight tasks and it had ways like doing supervision hierarchies, and I went Erlang, but fast. Like, I want that. And the way Erlang comes is it's like a bundle of stuff, right? It's not just a programming language. It comes like, it's got its own VM with special properties, and it's got a big library of stuff you have to do. It'd be basically pointless to do anything with Erlang, just a programming language. And so I really wanted that. But now, though, especially sort of to your point, and maybe this is where part of your perspective comes from, as we've veered into bare metal, we're literally trying to get a crazy high-end SoC, network SoC just to boot itself, basicly. And nobody at that company knows how to do it without their big binary blob, which was super fun.
Right.
Yeah, it's god awful. Anyway, that we ran into some stuff, a lot of stuff actually in Rust, where it was like, oh, well, they've picked a way to do this that is like, if you were running on Linux, and you kind of expect to have something that is operating system shaped here, or it's a very particular way of solving the problem. And then we would have to build a lot of stuff on our own. We would just be building from scratch. It was like we were building our own little weird standard library for these things. And that was kind of tricky, because what I took from your, don't veer too far down this is, it's very easy to get excited about pulling on a thread that looks like it's really interesting and spending a lot of time and community resources kind of going down that channel without getting breadth first on the ways in which, and the right abstractions on what you can build and how you should go about it.
Well, standards are good in that they get everybody doing the same thing, but they also lock you in.
Yeah.
And
yeah.
So, the closer you get to hardware, the more you appreciate the OS. The OS is there to insulate you from worrying about things like memory coherence across core complexes and silicon errata, unfortunately. At Green Hills, we're often the one that everybody points at. Green Hills, you're supposed to protect me from this chip bug. And it's like, well, shoot, we didn't know it was there. So, getting an operating system, getting IPC across a memory hierarchy is hard.
Yeah. We did that with SEL4 with our, at some point we'll open source it. It's just we're trying to get our product out, but we have this little operating system that we wrote in Rust on top of SEL4, and it was dealing with the memory models between like x86, the different flavors of ARM32 with hype or without hype, and ARM60 is god awful. But yeah, it's hard.
It's ugly.
So real quick, we're getting to the end of the hour actually already. So I wanted to leave with one quick question, because you started touching on the difference between different languages, standards, and what they did and what they didn't do. So I talked this morning a little bit about sealed Rust, which aims to have a formalized subset of the Rust language. So as kind of a closing thought before we take a short break and come back to answer questions, I'd be interested in hearing what each of you think about what could Rust learn from these other language standardization or even a tool qualification or formalization process that you think now, with the benefit of hindsight, that Rust could really learn from? So Jack's already talked a little bit about not veering too deep and trying to cover everything with a language standard, because you'll find out that certain things like an operating environment don't do a great job of hiding that all within the language itself.
I'm curious, like Nico's thoughts on this.
Yeah, the last two questions are really hard, I think.
Yeah.
So, yeah. In general, the first, and I will rely again to the standards. I don't want to be overly seen as a standards person, because I'm not. It's important on any kind of system that you want to build that it's safety related to have a clear safety culture, and perhaps this is something we could build in. The ecosystem is super young. It's easier to revert changes or direct our efforts towards a certain direction today than in 10 years from now. It's super hard to change what the C++14 has done or the C99 has done today than when it was actually developed, this standard. Of course, that being said, the Rust RFC processes, the working group processes are excellent, and I think perhaps it's not that of a hassle. And another thing I would really like to investigate eventually is how do we qualify the compiler? The Rust compiler has a humongous amount of testing. I mean, if you look at it, you will say this is an excellent piece of engineering work. And we don't appraise them too much. I've never met the people, but if I meet them, I will buy them a beer for sure. And many commercial compilers today don't have this level of quality, even though they are not, even if they are qualified compilers, perhaps in many cases. So perhaps Rust is doing already many great. It has performed many of the base practices that safe software is doing. And the thing is that we need to put out that word, and that's why I really appreciate your work, James, with this Sealed Rust initiative. And perhaps I came back. I received a message that I'm coming out as a very negative person towards this Rust to safe system. I'm absolutely not. I'm absolutely not. I'm only in favor, and we started we put a lot of thinking trying to push Rust in the organization of Volvo today, and yeah, thankfully we found some hearing people. But to wrap up my previous comment is that at the end of the day, perhaps to just archive all the efforts we have done to show how great the compiler is. I mean, this is already a selling point compared to an unknown compiler you might buy for Synopsys, for example, or that is an unknown quantity. You need to sign, I don't know, 30 tomes of NDAs just to get a peek on their test suite, for example.
Yeah. So I definitely want to mention. So I come from an avionics background, and I actually do have a very positive view, especially about the spirit of these safety critical regulations. Is that most of these regulations, the comment in avionics is typically every regulation is written in blood. In that every single one of these processes are there because they're responsive to some accident or something that happened. And I'll be very honest. We're being so aggressive, or Fair Systems is being so aggressive with Sealed Rust because we've been a part of the compiler development process, and we've seen the huge amount of engineering care. And coming straight out of avionics, I was still just leaving avionics when I saw Rust for the first time, and when I saw things like the test suite, things like the RFC process, I went, yeah, they get it. Like that's that's exactly what an organization needs to be doing. And I've definitely seen through some consulting work and things like that, some organizations that were in safety critical industries and didn't have their process as well together as the Rust organization, just as an open source organization. So I'll tell you very sneakily, the reason that we're pushing so hard on sealed Rust is because at least I have a lot of faith that people are going to be really surprised by what's already there. And a lot of what I mentioned in terms of the work that needs to be done is the paperwork to show these regulators and to show these companies that are interested in using Rust that the quality is there. And yes, there's probably some, last 10% of rounding corners and things like that to make sure that that due diligence is really done all the way to the level that's needed for safety critical. But we're here because we think that generally the quality is there and that it's a very achievable goal. The date might be, something to argue about, but that it is something that we believe that the Rust language can do.
Yeah, I wanted to say I want to say it was BMW Car IT, but I can't remember off the top of my head. At one point, somebody, I think the paper was from like 2013, and the onus of it was to try to figure out like what could they adopt from the Linux ecosystem in terms of qualifying something that kind of trying to figure out like, if they could qualify something that kind of already existed. And most of the effort was looking at the processes for development. And kind of part of what they landed on was that the mailing list, had all this context in it that was way more rationale and thought that went into, that was visible, right? Or that went into every decision that was made, which is a really important thing in safety critical systems development. You want the connective tissue between like why you did a thing to that you did it, right? And be able to connect one to the other. And the RFC process in Rust is fantastic for that. Like you get to see, there aren't very many other places where you get to like go and look at the people who are putting it together, who are like vehemently and vigorously considering all the edge cases that they can think of and documenting it and going back and forth with one another and then getting that into something that eventually becomes a feature, right? Or some, new capability in the system. And sort of to Nico's point, like on like the compiler quality, it's a similar thing where you're like, well, this is much more than you would, maybe get in any other organization that's sort of like following the standard, but it's not, it's like, it's all happening in parallel with no knowledge of the fact that it could be totally applicable to this like other domain. And there's gotta be maybe some effort, which I think sealed Rust is, going to be a part of, which is like trying to go like, okay, what can we pull from that? And then figure out how to align that with what people expect. Like, Jack mentioned like in the private chat that like I had surprised the assessor, which is true. And that while yes, it's like can be annoying to be doing something, developing a compiler in a better way, right? Going through and doing the requirements like process in a better way than these other sort of ecosystems or companies or enterprises do. You still have to do it. There's an amount of the game you have to play, right? It's like you don't get to go like, I'm a cool kid and I don't have to do any of these things. I tried doing that with fundraising and it was a colossal failure. So like I need to figure out how to play the game and go out and change how I wanted to go about it, or how they wanted me to go about it. But it is it is one of the things that has been like most impressive to me about the way like how fastidious and considerate of the decisions that they're making the Rust community is about what's going on now. They end up sometimes disagreeing, and there's lots of features that don't make it in that I wish were there, that I've been like on the table for 10 years. But nonetheless, like I get to go back and look at the rationale, right? And that's often what is going back to your very first question, James, about like what's different between safety critical software and other software. That's another big component that I hadn't thought of, which is that safety critical software requires you to retain why, and regular software only really gives a crap about how. Right. And so like you have your test, you see that it works, like why is always lost to the archives of Slack or something. Right. And safety critical software doesn't, you don't get it to have that. Being able to maintain a process for why is an essential component of that.
One of the most upvoted questions in the chat was from Adam Gray, which is, with Rust dependencies, it's very common to have hundreds of transitive dependencies, which is much less common in traditional C development. Is that likely to make certification harder? And do you think certified safety critical projects will have much smaller dependency trees and therefore lose what might be seen as one advantage of cargo? So I'll throw it up. Whoever wants to take that one first.
I asked my engineers like cargo was the source of much consternation. So it's a great tool so long as you can do all the things that it expects you to do. It's very opinionated. The suggestion from my engineers was that maybe there's a world where you decouple the building from the dependency management, and that way you have like a slightly more flexible way to interact with this thing. Because there was one point, for instance, this was where we got to the pathological case where we were trying to work around a cargo bug where it was unifying all the dependencies in one namespace, and we made a crate called like cargo 1576 or whatever. I think it's since been fixed, maybe in the most recent cargo, but
I think it's in nightly. I think the fix for it's in nightly or maybe even beta now.
Yeah, thank God. So, but what we ended up doing, the first pass at it was like, okay, well, let's just try to use cargo's. Let's see if we can sort of make a thing that as a build tool that uses cargo to fix cargo. And so we tried to use cargo as a library, and I think it imports the entirety of crates.io in order to sort of build itself. And it's tricky because like I think Jack brought this up, is that when you're dealing with these legacy systems, like you need to be able to ship a shared library. There are certain things that the cargo toolchain like really makes hard to do unless you're just going to go, I'm all in on cargo, which is what we did. We now have taught cargo to do a bunch of other stuff rather than using, we have a bunch of tooling for like how to get it to interact with CMake for these underlying dependencies. Because what are you going to do? Like it's just what we're stuck with.
Yeah. Do you build up cargo or do you build around cargo? And, so far I've taken the approach of building around cargo. Yeah. And, to the question about the deep depths, C programmers and C++ programmers, they've never dealt with a repo before. So cargo is just, an amazing light to them. I've dealt with repos, both good and bad. I'm sorry, Java people, I don't know how you work with Maven. Every time I try to build a Maven project, the dependencies are broken. But cargo seems to always work as long as you're dealing with crates.io. So, when it comes to safety critical, I think that it's not necessarily cargo that's the issue, but maybe it's the ecosystem. People build on everything because it's easy, and that's where you get so much leverage, especially from open source. And in safety critical, boy, you really have to curate the crates that you're going to use. They have to be either certified as safety elements out of context. They either have to provide evidence so you can certify them in your component. So I don't think that you're going to get these, depth chains 100 deep in safety systems, because you just can't have that hands-off approach to code. More of it has to be yours in order for you to attest to its safety.
Yeah, go ahead, Nico.
Yeah, this is not only a problem for a safety system. If you have any kind of embedded system, you need to curate your dependencies. Yeah. There is no way around it. And our little node that we're building that has no safety requirements, one of a lot of work or thinking we're putting on is how to properly deploy with cargo vendor, how to properly store our crates, how to review the crates that are incoming, because there might be not safety problems, but security problems, for example, or
license problems.
License problems as well. It's the same. It's a set of problems that it's not the same as safety, but it's the same cluster of problem. And you definitely need to curate your embedded world anyway. Perhaps somebody doesn't have a MIT license, for example, something from the things you are putting, license. Yeah. So I think it's not only, this is not a safety problem only. It's all over the place. If you're deploying your code not on a web server, but also on your little silicon.
So I definitely want to call out a couple things where there's definitely some building blocks here, and it's part of Ferris Systems and the exercises we've been doing to figure out what is needed for a sealed Rust ecosystem. This is definitely one of the things that we've highlighted, because there's a reason people like reaching for dependencies, and that's because often it solves a problem for them. When we talk about faster iteration, that's one of those things where you can pull something off the shelf, and especially with Rust, you tend to have a high chance that when you pull something off the shelf, it's generally going to work. It's maybe not totally matched for what you're trying to do, but generally things tend to do what they say on the label. But there's definitely two projects or components that I want, or three things that I want to point out that I think are some really interesting building blocks. And I'll at least mention that I'll tell you, Ferris has been looking at them as possible building blocks towards a safety critical sealed Rust ecosystem, or even a mission critical, like you said, security dependent libraries. And one is that Cargo has a concept of lock files and things like that. And you can have general guarantees that you can specify very specific versions and be assured that the version that you chose is the version that you chose. Not everyone uses it as stringently in Rust, and that we tend to like the newest version of things, but it's certainly possible to lock that down. The second thing that I wanted to mention is it is possible to build an alternative registry today. Crates.io is used because everyone uses it, and that's a lovely thing. But there is infrastructure and the possibility, and there are already proof of concept package repositories that are not Crates.io. And that's something that we've had customers ask us of what it would take to set up an internal version of a Crates.io, which could use packages that internally companies had approved to some level or another. And the third project that I wanted to point out is something like Cargo Crev, which is a code review tool which is meant to distribute code review and things like that. What it aims to be is essentially an allow list of I've gone and done a security review, or people I know and trust have gone and done a security review on something like this. And then I could very much see either a company that is large enough building one of these internal repos that have an allow list of crates that they've said, look, we think that being able to bolt these parts together is still valuable. I've worked at safety critical companies that had internal software libraries. We say, this is the math library. This is the real-time kernel. This is the GPS location processing library. And we've qualified those and codified all of the integration requirements for that. And that was a huge accelerator for development at these companies that I've worked with. And I think Cargo and the tools that come with Rust can only serve to accelerate that, but I think someone needs to write the operational playbook for that. But it's definitely something where I think a lot of those baseline building blocks are there, or at least the concepts are there, and the ecosystem has thought of them. And certainly it's something we're looking at Ferris Systems of what would make sense, whether that's a subscription review service or providing these libraries as safety out of context elements that are reviewed to different standards and things like that, where you can say, I want ASIL B, or I want ASIL D, or I want DO-178 level C, or something like that. And you get a mapping of crates that are acceptable for use for your application, because I don't think people are going to give up on that ability to use building blocks and have packages, but it has to be in a way that makes sense for the context.
Yeah, Nathan, I've talked to people who, when we talk to them about embedded Rust, the very first thing they say is, make sure Cargo's there.
Yeah, totally. No, Cargo is fantastic, right? I mean, that's the thing. It's like, but it's sort of like what you were saying with the operating system stuff, where it ends up being it's a complete solution, and as a result of being a complete solution, it's very opinionated, and then has degrees of calcification and inflexibility. And if you're starting from nothing, then it's it's very easy to adopt. If you are starting from Daimler's build system, right? It's like a whole different can of worms, right? And I think and that ends up being a challenge, because then you end up in this situation of constantly relegating. So people may not be aware of this, but in the automotive industry and other similar industries, there are three-ish basically primary phases of development, where you have R&D. It's mostly the artifacts that come out of R&D are white papers that go to advanced engineering. Advanced engineering figures out how to make the thing, and then production engineering figures out how to make it cheaper and reliable and get it out there. And so if we can't figure out a way to provide the necessary flexibility to onboard this thing into existing ecosystems, not just as a language like with an FFI, but with the tooling, it will just be constantly relegated to the bin of R&D. And that's not great. It's cool. You get to it gets to inform what happens in advanced engineering, production engineering, but it doesn't get to be the central thesis of how things are developed.
Well, maybe
so I want to
Cargo. Well, I was going to harken back to Nathan's comment about maybe fetching should be separate from building. But back to you, James. You're the moderator.
Yeah, definitely. So we have a lot of great questions, and I want to at least hit some of them while we're on video. So the next question that I really liked is, what is the most impactful thing software engineering in safety critical systems could improve on, independent of certification from outside, which is frequently sometimes just a paper trail?
So understanding the use cases of your library, or how somebody else would use your library, your crate, or whatever, regardless of the language or the environment, is the number one thing that most certification or qualification will look at. So have you documented your assumptions? Do you have some sort of safety manual for what you are deploying? So from that perspective, and that's exactly my point about Rust community processes, is that we document, the community itself documents all these decisions so nicely. Why can't we do the same for our crates? Why can't we do the same for having a great rationale for what we're doing inside our crate? I think that would benefit not only for the certification process, but also somebody that is a newcomer to your and wants to contribute to your library. You have documented your assumptions. It's easier for them to understand your thinking or the purpose of your crate. So we shouldn't see it as only a paper trail. I do believe that there are benefits to be reaped out of this of such a mentality. I mean, as long as we don't overdo it. As long as we don't overdo it.
Definitely. I do a fair amount of safety critical consulting, and particularly I find myself talking to a lot of companies that are new to safety critical, in that they typically come from a more consumer background, or they come from a more startup culture. And that's one of those things that I feel like a lot of people take for granted. If you work in an organization that has a 20 or 30 year safety culture, in that introducing a safety culture is a huge thing. And I don't have it with me. One of my favorite books is Better Embedded System Software by Koopman. And he has this wonderful concept of just enough paper, which is talking about you should do the things that bring you benefit. Because if you're just doing the paperwork to do the paperwork, you're paying the cost twice, because you're going to develop something bad and you'll spend a lot of time doing paperwork. But the concept of do the paperwork actions that bring you value. And when I sit down with an engineering organization, they're like, what tools should we use for safety critical? What MISRA checklist do we need for safety critical? And honestly, the first thing that I go to them the first time is, if you only have 1 week, 2 weeks, 5 weeks to improve your process, sit down and have good requirements. Because that's honestly by far one of the things that the safety critical standards enforce the most. And the number one thing that provides the most value is sitting down and writing down, what is my system supposed to do? What is it not supposed to do? And what are the edge cases around those two things? And those are one of those things, I'm not sure how Rust can always help that. I think Rust has better ways of encoding that into the type system and into the programming language itself. But I know I would love to have a better traceability tool, the ability to say, these are the requirements for my crate, and these are the tests that fulfill that, and this is where I implement this requirement and things like that. I'd love to have an open source traceability tool that let me write software requirements and map them to code, because that honestly is one of the lowest cost and the highest. That's like the first 80-10 thing that I do with every engineering team, is get them to sit down and actually think about their design for the first time, because that makes all the difference.
Yeah, good requirements is a prerequisite for good testing. And anything that makes requirements easier to write, and in particular tie to code. You know, it's one thing to mark code, but if we could, as a safety community, develop a more structured language for requirements. You know, English is a terrible spoken language. Any written human language that's used for interpersonal communication is generally not a good language for specification. But yet we have to tie thoughts, written thoughts, to code. And anything that we can do as a community to develop a more structured language that's still a human language, because it's human thoughts and things we're building for people to use, to code, that's something that I think would, you know, help that testing problem. You know, I've dealt with traceability where we marked things and looked through dependency trees of requirements, and you get some weird side effects when all you do is label. You're like, well, why does this test here cover that requirement there? Oh, because it only covers 5% of it. So without having some knowledge encoded in those labels about the function, That's something that's an improvement that we need as a community above and beyond the actual language that we pass to a compiler that produces code.
Yeah, that's like one of the things that we did early. It had been like aim higher, kids, because this dream is not that high up, what I'm about to say out loud. But what it's not like becoming an NBA player. We created this little library or sort of framework internally that we called Kosher, and it'll make sense in a minute why. Which was the ability to create custom dialects of Gherkin, which is like the cucumber programming, not programming, but like feature specification, sort of like some scenario label, given some precondition, then something happens, or when something happens, then some result occurs. And in the typical use of cucumber and Gherkin, I don't think that they took the concept as far as they could have. Mostly it's used as like a test runner, just to like, pattern match against the string and go, it's just step through these scenarios and run whatever the test is that it matches to. But that, given when then is a very propositional like sort of structure of how to describe something in a way that you can get some English in there alongside of some specific like keywords and tokens that have maybe particular meaning. Of course, then like what the meaning is a whole separate like corpus of challenge to deal with. Yep. But then we did things like making it so that we could generate property-based tests and models like from the things that we wrote down in the requirements. So when we were first started out as a company at Oxon, we had this big, engagement with a customer, and we wanted to be able to do what you were suggesting is like, let's get from what they expect, because they did not have a lot of requirements, which was kind of a problem for us. Because then we were discovering what their requirements were. And so, but we would write them all down in this sort of quasi-machine checkable way. We would generate the basis for what the property-based test should be, like from this specification. And then we still had to go in and like fill in the property-based test and maybe write the generators and things like this. But it did give us this way to start to expand a little further, right? Like how far from high level, like very loose requirements down to the evaluation in a domain exhaustive, right? Like property-based testing exhaustive, like way of this like feature that we had to implement, or even integration level capability. I mean, I think that's one of the things that's really hard about doing what this sort of like requirements down.
I'm going to pause you. I'm going to pause you real quick, Nathan, because we've got about 7 minutes left, and there's two questions I definitely want to hit. So the next one is, where is it? I got too excited and lost it. There it is. Since Rust handles 70% of the bugs that are memory safety related, how do you imagine safety critical systems designers and testers will squash the remaining 30% of bugs that are inherently more domain specific?
Well, look how much time they have now. They've got more time because they don't have all these other bugs they have to go chase. Shoot, we just eliminated 70% of your bugs. Now you can spend time writing tests that look for other types of defects.
Or 70% more time to write new bugs.
You mentioned that, but that's one of those things that really, like those deep and hard to find integration bugs, which is usually where those memory safety bugs shake out. Those are the worst because they're usually not super reproducible. They're not like, oh, I found it. It's like I had to wrangle a debugger for 6 days until I found the trail. And then it took me 6 more days to hunt down the trail to find the one place where someone was 1 byte off and corrupted my allocator or corrupted a lookup table. It really is, even if it's 70% of bugs, it probably takes up a huge amount of the debugging time that you spend. Where you hope that the rest of them are your requirements were wrong and you just have to go up and update your state machine or something like that.
And think of all the code reviews where you're looking for the freeze, So yep. That's what we'll do. That's how they'll squash those remaining 30% is with all the time they're not spending debugging all the others.
Yeah. So I want to end on this question because I think it's a really good question, and I'd love to go around the room and hear a little bit or a couple of thoughts from everyone here. So the last question I want to ask is, what would and can you do now to create the distant future we're envisioning right now? So I want to start with Nico on that one.
So if I would start today, I would go to a couple of my favorite crates, hitless. It's my really favorite crate, and Cortex MRT also, and all the dependencies they funnel in, and start having this safety and perhaps security, because cyber security requirements are also coming. Perhaps they are not under a safety standard, but they will eventually become. The more autonomous our cars become, this will also boil down to another similar kind of standard eventually. And I will apply this safety culture. I will have similar processes like the Rust would have. There is research that the extra effort to apply just these base practices for safety development is between 30 and 70% extra effort. I know that it's kind of a lot, but for those crates, I would love to have this mentality towards safety, documenting the assumptions, and moving forward. And eventually, we will do it one way or another, Volvo or not. This will happen because Rust is a great language, and we want to move forward with it. We don't want forever to be tied in a C ecosystem, I think.
Yeah, and I think that's something, I know the Rust Embedded Working Group is pushing a lot of those infrastructural crates towards 1.0 now. And I think having engineers who are interested in using safety critical systems being able to weigh in on that and help to improve the documentation and even the statement of what the expectations are is definitely something that's very interesting to get that kind of mindset going and trained and start spreading that knowledge throughout the embedded ecosystem before you're taking it to task, if you know what I mean.
Yeah, and 10 years from now, the kids that are in high school doing FIRST robotics and doing hackathons, they're going to be the engineers coming in.
Using Python.
Not if we intercede. So this is an ST Nucleo board. You can get an Arduino load for this, but this is what you plug into the current embedded Rust project. It just works. If you're an educator or no educators, start running hackathons in high schools with these. Build your first robotics on top of this. It's ready to use. Write code. That's what I think we all can do to help the world use Rust more in the future. Write code.
And spread the word also, Jack.
Yeah, I will say last year, Ferris Systems sponsored a FIRST robotics team in California that used Rust for their robot. So there has been at least one FIRST robotics robot that is already using Rust. So Definitely check that out. And if anyone's watching this that is doing FIRST robotics, this year might be a good year to use Rust for your robot, because I know they blazed a lot of trails and they started putting all of their work on Crates.io. So there's already crates on Crates.io that will help you build FIRST robotics robots.
And the hardware's cheap and available.
All right, Jack, anything else that you, oh, sorry, go ahead, Nathan.
Yeah, pass it to Nathan.
Because I had to move mountains at Visa. I always think about, what am I going to get? How am I going to get an institution that is very resistant to, at multiple levels, to do a thing that it doesn't necessarily, that it's inoculated against, basically, right? Like every single one of these institutions is basically has an immune system to keep stuff like Rust from actually gaining traction anywhere, social, political, whatever. In addition to going out, and just getting oneself familiar with, the real time for the masses project and things like this, where you kind of get to see how you can leverage the features of Rust to just never arm yourself with the foot guns that you would normally lose toes to when you're developing sort of complex embedded things. I think that both Jack and Nico are right there. In terms of trying to bring it into an organization, and I'm actually curious to hear more specifically from Jack and from Nico on this, but my advice and experience has been find something stupid nobody cares about and start there. And even if it's in your free time, and being able to sort of as an example of showing what you have to find a way where there's fewer eyeballs to show them what the future can look like. But I mean, that's how it's worked for me in the past. But I'm curious, say at Volvo or Green Hills having to be the version of that, constantly across multiple customers, what that looks like for them.
Well, certainly, it with my Green Hills hat on, it's incremental. It's crawl, walk, run.
Yeah.
But, personally, I'm a geek. I do hobby projects. I long ago stopped doing them in C and C++ because it just wasn't efficient. I've got Java code that I play with. It's 15 years old and just keeps running. And I keep adding to it when I want to. But most of my hobby work over the last, I'd say, 3 years has been done in TypeScript. Because with Node, I had a great package manager. TypeScript is a great language, unlike Python and JavaScript without type checking, where you don't find out you have a typo until you run the line of code, which maybe 15 or 20 minutes into your machine learning run, But now with Rust, I've got a great language. I've got great tools, just like with TypeScript. I've got a great package manager, a wonderful community. So it doesn't have to be commercial work that you do. Write code.
All right. Well, I think we're going to wrap it up there because we're getting close to our next talk. So I want to thank all of our panelists today for coming out. I know it was we've spread a lot of time zones here, but I really appreciate all three of you being here today and helping to address some of the items moving forward for Rust for safety critical systems. So thank you all very much for being here. I can't thank you enough.
Yeah, that was great. Thanks very much.
Thank you, James, and thanks to my co-panelists. It's been good chatting with you folk.
Yeah, likewise. I'll take this offline and keep complaining and dreaming.
I have get together and have a beer sometime.
There you go. Come on out to Berlin. Okay. Well, we have luckily thankfully the Ferris folks put together a HackMD document with all of or at least the first questions that we curated. I'm going to drop a link to that in the chat so that we can kind of refresh ourselves on the questions that are out there. And I'm going to drop off and let us go to break before we come back to the next talk.